Hi, hello everybody. Thank you for watching this. In this presentation, I'm going to introduce a recent experiment that I have conducted, which looked into the phonological co-activation in bilinguals two languages during production through using the phoneme monitoring task. The presentation will start with a brief introduction, as usual, of the topic, and then it will move into introducing the research problem and objectives. Then it will explain the methodological approach that is used and the methods of data collection. The last part of this presentation will introduce the results and the findings of the study. The main focus of my thesis is lexical access and speech production. By lexical access, we mean the process of retrieving a word from the mental lexicon during production. So how does this happen and what processes involved? Studies in word production, they try to answer questions like, are the bilinguals two languages active during speech? If so, how does a bilingual choose only a single word in production over the other one? And the most common findings in the literature is that the two lexical nodes in the two languages are active, and that the non-target lexical nodes in the non-target language, they may interfere or facilitate in the selection process of the target lexical node. So let's take a closer look at the stages and the processes involved in each stage. So the current models of lexical access in bilinguals assumes that there is a shared concept system between the two languages of a bilingual individual, but they have two separate lexicon. As you can see here, there is one conceptual system, and here we have two lexicon. For example, if this is an English-Spanish bilingual, he would have two separate lexicon where they store the lexical nodes. Each conceptual representation is connected to its corresponding lexical nodes in the two languages. And each semantic representation, they spread the activation to the lexical nodes in the two languages at the lexical level. As you can see, if bilingual, let's say for example, want to name a picture of a cat in the second language, in the target language, or in the non-target language, L1 or L2, whatever is the scenario. So first the conceptual representation get activated, and then these representations spread the activation to the corresponding lexical nodes at the lexical level here. As we can see, several lexical nodes in the two languages are active. So the main focus of this study is that, this is what we call the parallel activation. The focus of this study is to see whether this parallel activation does it extend to the phonological level, as the production process involves four different stages: the conceptual level, the lexical level, and the phonological level, and lastly, articulatory level. We want to see whether this parallel activation reach the phonological level or not. So basically, we want to see whether these activated lexical nodes at the lexical level spread activation to the corresponding phonological representation at the phonological level. We have two objectives for this study. The first one is to investigate whether the phonological representations of the non-target lexical nodes are they active at the phonological level or not. The second objective is to see whether the proficiency level affects the cross-language activation, this parallel activation, in other words, or not. So in this study, 86 Arabic English adult bilinguals were recruited in this experiment. We divided them into two groups according to their proficiency level, the less proficient bilingual and the other group for the highly proficient bilinguals. We used different proficiency measures like the IELTS test and an online lexical decision task. And then we selected 15 phonemes that are largely similar in English and Arabic. The selection was based on a published comparative study of the phonemes in the two languages, Arabic and English. And then for the phoneme monitoring task, we asked the bilinguals to focus on a screen and decide whether the presented target phoneme is part of the English name of the target picture or not. Let's take, for example, the word mouse. Mouse in Arabic is far. So we will present a phoneme at the beginning. The first slide is for the phoneme, the presentation of the phoneme. This is replaced by the picture of a mouse. Now, we have selected 3 different phonemes corresponding to 3 different experimental conditions. In the positive condition, the phoneme is part of the English name of the picture. Let's say M, the first sound, okay? And then in the critical condition, the phoneme is part of the Arabic name of the picture, which is F, far. Now, in the control condition, the phoneme is not part of the Arabic name or the English name of the picture. Let's say the sound D. So, in these 3 conditions, we expected bilinguals to provide a negative answer to all of these conditions except the positive condition. Now, we hypothesize that if the other language, which is in this task is monolingual, which is performed in English only. We hypothesize that if the L1, which is Arabic, is activated during this task, then we should see slower performance in the critical condition comparing to the positive condition or the control condition. In other words, we expect to see longer naming latencies in the critical conditions relative to the other conditions, because it will be hard for the bilingual, if L1 is active, it will be hard for them to reject the phoneme and provide a negative answer for that condition. Whereas if the L1, the Arabic, is not activated, the naming latencies should not be different than the control condition, as both of them should be negative answer. On each trial, participants were first presented by a fixation sign for 500 milliseconds at the center of the screen, and then this is replaced by an English target phoneme, which remained for 1000 milliseconds at the center of the screen. Then the phoneme was replaced by a picture of an object, mouse like in this example, and the picture will remain on the screen until participant respond or made a response. If the phoneme was part of the English name of the picture, they have to click yes. If it's not, then they have to click the no button. The whole task was created through using PsychoPy because it was conducted online due to the outbreak of COVID-19. As for the design, it was a mixed design with proficiency as the between subject factor, highly proficient and the less proficient bilinguals, and the phoneme time in 3 conditions, critical, control, and positive condition, representing the within subject factor. As for the statistical analysis, we used mixed ANOVA analysis on the mean response latencies and accuracy per subject and per items. As you can see in this table, the result indicated a significant mean effect of phoneme time in the analysis by subjects and in the analysis by items. Also, we found a significant mean effect of proficiency type in the analysis by subjects and in the analysis by items. But we did not find any significant interaction between phoneme time and proficiency in the analysis by subjects and in the analysis by items. We conducted a per-T test to examine the significance of the noted differences for phoneme type. As you can see in this table, the average value of reaction time in the critical condition was significantly larger when compared to the control condition for the high and for the less proficient bilingual. Here the size of difference is 0.47, and here the size of difference is 4.6, and the results of the t-test was significant. On the other hand, the average value of reaction times for the positive condition was significantly smaller when compared to the control condition. As you can see, the difference of 0.24 for the highly proficient bilingual, and here of a difference 0.29 for the less proficient bilingual, and the size of the effect or the difference is large. Finally, the average value of reaction time for the critical condition was significantly larger than in comparison with the positive condition for the highly proficient bilingual and for the less proficient bilinguals, and again the size of effect was large. Calculated coherence was more than 0.8 for all comparisons, indicating a large effect size. To investigate the noted differences for proficiency level in all three conditions, we conducted a follow-up independent sample t-test. As summarized in this table, the average value of reaction times for the highly proficient participant was significantly smaller than the less proficient bilinguals in all three conditions. In other words, the highly proficient bilingual were faster when rejecting or accepting the phoneme in compared to the less proficient bilinguals. The size of difference was large in all conditions. As for the analysis of accuracy data, the result of mixed ANOVA showed a significant main effect of phoneme type and a significant in the analysis by subject and in the analysis by items. Also significant main effect of proficiency level in the analysis by items and in the analysis by subject. An interesting finding is that we found a significant interaction between phoneme type and proficiency level in the analysis by subject and in the analysis by items. And we believe that the reasons for this interaction is that the difference between the less proficient and the highly proficient bilinguals in the critical condition, as you can see here, is larger than the difference between the two groups in the other conditions. As you can see, the less proficient bilinguals they performed poorly in that condition compared to themselves and compared to the highly proficient bilinguals. This shows that the less proficient bilinguals they were having or experiencing hard time rejecting the L1 target phoneme during the production or during the process, the processing of L2 words. But not only that, they were having less control over L1 as being the dominant language here. That's why they could not help but accepting the wrong phonemes at that trials. So the results demonstrated that though the task was based on monitoring phonemes in the English name of a picture only, the phonological representation of the non-target lexical nodes in Arabic were active at the phonological level, as participants were slower at rejecting L1 phonemes compared to other conditions, and they were also error-prone in that condition. The result also revealed that proficiency level does not modulate the cross-language activation, as the same pattern findings were found for the less and the highly proficient bilinguals. Thank you all for watching this, and looking forward to see your comments and feedback. Thank you.